Good morning. So I guess it's time to start our next lecture. And today's lecture, number 4, is going to be about sentiment analysis. Very important topic, very useful topic, and very mature and huge research direction when it comes to machine learning. So every time when researchers or businesses talk about social listening, when they talk about data analytics for advertisement, for media, they talk about sentiment analysis. Because sentiment analysis is one of the techniques that helping brands to figure out how do audiences respond to their opinions, help politicians to figure out what is their public opinion about their policies, help business and finance to predict the future stock price and many other applications. So we're going to talk about a couple of topics about algorithms, about lexicons, about other sentiment tasks, and you can refer to the articles here, and then also begin some articles in the end. And these articles are very much all about sentiment analysis. So I guess in your lab 1+2, you can actually use many of the techniques I described today, and you can just adopt them directly from the lecture. And once you adopt them, you definitely get better performance, and that will be a really big plus for you when it comes to evaluation of your results for your labs. So when we deal with sentiment analysis, we want to basically identify the direction, orientation of the opinion, whether it's, let's say, positive or negative, and many some other different types of combinations of that, right? But the simplest way is we have, let's say, movie. A movie can be maybe good. Movie can be just like somebody can just give the fact that, you know, that a movie is about this particular hero, and somebody can say, oh, a movie is horrible. So it's again sentiment, and it's a negative sentiment. So this is sentiment, and this is ground truth we analyze, and this is basically what is sentiment, how we define our task. We can have many more types of sentiments. When we talk about movie reviews, particularly, there are many other in-between type of sentiments, and even some controversial statements about the same thing. And generally, this is quite common for user-generated content to be either controversial or providing some not that obvious type of sentiments and opinions about the movies, or maybe some particular post, other posts, etc., etc. So the first one is unbelievably disappointing. It's definitely negative sentiment. The second one is probably positive sentiment, full of zany characters and which apply straight and some great pilot tweaks, right? The great is one of the keywords. The third one is also positive. There's the greatest screwball comedy ever filmed, right? But also the last one is a negative sentiment. It was a pathetic. The worst part about it was the boxing scenes, right? So this is like example of movie reviews. But we have other examples. We can have Google with their product reviews. We can have the same thing on Bing with reviews. We can have even stock prices get predicted by the sentiments of Twitter, where Twitter actually follow together with the stock price. And that's why Twitter is very often used, in fact, and many researchers do research, like a paper you see in the picture, that is about basically correlating the sentiments with other real-world applications, such as stock price, and trying to figure out what is the relationship between them. So this is all sentiment. Particularly if you go into Twitter, we can handle more precise information and more detailed information about what is going on within all these sentiments. So you can see, for example, you can use Twitter as a sensor for the different situations. So if you see the top plot, it, for example, reflects the elections of the president, and also the Thanksgiving celebration. So you can see that election get a two type spike, and Thanksgiving also get a spike, but there were no other spikes around. And at the same time, you can also look for different types of sentiments. Let's say the calm sentiment get really very low, right? The level of calm get really very low on the pre-election day, so everybody not calm. And you can also get alert, sure, vital, kind, happy, and other type of feelings or sentiments that can be measured by the tool called Opinion Finder. And that basically this all can be features, and also this all can be very good predictors of the sentiments and therefore predictions of different events happening around the globe. So there's some other research. Basically here you can see that also sentiment can be predicted very accurately, and you can see that at the same time this sentiment can be, let's say, not just correlated with some public events or stock prices, but with other real real world examples, such as in the different industries such as banking, etc. So you can see that, like, for example, I mean, if you're familiar with finance, you know that there is such thing as a hedge funds, and one of the hedge funds that this researcher are working with is actually using exactly this algorithm by detecting the bank bailouts, right, inside the plots. So this is financial schema, and there are many others. So I don't go very detailed, but we can have many other sentiments, and Twitter itself through the API even provides the sentiments with relation to different topics. So there are many other names: opinion mining, sentiment mining, subjective analysis, opinion extraction. They all mean pretty main thing, and there are also many areas where it get applied. So it get applied, of course, for the product and movie reviews, for public sentiment mining in politics, in US election politics, and also gets even prediction election outcomes and market trends based on the sentiment, especially in such social networks like Twitter. So therefore, there's a Shirtle typology for this have been invented to handle this, and they basically differentiate a couple of particular types of sentiment that can be distinguished. So emotion is maybe angry, sad, joyful, fearful, etc. There's also can be mood, like our mood in this current moment, and that can be like cheerful, gloomy, irritable, distress, and the rest. It can be some interpersonal sentences, something like not related to particular personnel, and it can be friendly, fabulous, distant, or cold, warm, supportive, contemporary. It can be some attitudes, like I hate somebody or I love something, and it can have personality-related sentiments or personality traits, such as nervous, anxious, reckless, morose, hostile, jealous, and etc. So attitudes is something that's very close to what we're gonna be predicting. And if you focus directly on the attitudes, if you look on attitudes, it's basically about the holder, the source of attitude, and the object of it. Also can be a type of attitude. It can be like, love, hate, value, desire, etc. Or it can have even weighted polarity. So it's a positive, negative, neutral, or together with the strengths, right? So it can be very positive, just positive, or it can be neutral, or very negative, or just negative, etc. So we have holder, object, and the type. So, like, for example, the guy say, this is a great book. Yes, so it's a positive sentiment, and there is a book, there's an object, and there's a holder. The guy who's saying that this book is great. And this is also opinion, that this book is great. So simplest task was for what we're gonna handle and we're gonna describe in this lecture is, of course, the differentiation between positive and negative sentiments, but of course we can think of even more interesting and complex tasks, like, let's say, ranking of the sentiments or splitting them into more groups. A more advanced can be take a target source, a complex attitude types, right? So with I mean, as we know in life, not everything is just either negative or positive. There's many other interactions that could be leveraged. And this lecture focus on these positive versus negative. So there are some fields of subfields of sentiment analysis. One can be, of course, sentiment classification, just the one that we described. But when it get applied to sentence document feature, based on some sentiments expressed by the author. So sentiment classification, for example, is very useful for personality identification. Very useful for text mining, where sentiment get classified and then used as separate additional features in your machine learning task. But of course, we also can have some comparative mining, right? When you identify some comparative sentences, and this is very common in the product reviews or movie reviews. Canon's picture quality is better than the Sony and Nikon, right? So, well, what it means is actually positive sentiment towards Canon picture quality, and it's a more negative towards Sony and Nikon, right? So that's why it's a comparative sentiment. So the relation is better, and this relation is to the aspect, which is a picture quality, and there is also entity 1 and entity 2, or entity 1, 2, 3. So one is Canon, then Sony Nikon is entity 2 and entity 3. So there are also opinion integration, when you integrate opinions from different sources, like expert review site, blogs, and forums. This could be very useful, let's say, when you want to predict stocks, you probably want to use different social network and see their people's responses to different social networks. Opinion, spam, and trustworthiness, basically to identify the likelihood that something is spam, or like how much you can trust this review, etc., etc. So we also will be talking about this a little bit on the next lecture about spam detection. Then, of course, opinion retrieval, basically figuring out of the opinion. So how to figure out which one is exactly the opinion of the person, and then use this opinion to use as a result for the retrieval query. This is also very useful because we can mine the opinions of doctors, of certain symptoms of the disease, etc., etc. Many interesting applications. And opinion question answering. So this one is more like, okay, somebody asks a question, it's information retrieval system based on this query question, give the response. What is the international reaction of the election of Robert Mugabe as the president of Zimbabwe? And then African observers generally approved of his victory with Western governments, strongly denounced it, right? So this is opinions generally approved and as well as strongly denounced. So we have a 2 minutes break. So there is supervised algorithms that can be used for sentiment identification, and let's discuss how this algorithm can be employed for the task of sentiment analysis. Okay, so stepwise algorithm. So sentiment classification of movie reviews can be a good good example of a polarity detection, and in particular on a IMDb movie reviews database, you can look it in a polarity data in a link below. So whether a review is a positive or negative. Actually, this is quite a complicated task, because if you read the typical movie reviews, sometimes even for human, it's really very difficult to figure it out whether this review is positive, negative, what exactly does the reviewer mean. And it appears that the first one is positive and second one is negative, right? But the words they use, the amount of negations and conjunction words they use is usually very, very different, very diverse, and therefore it's quite often hard to figure out whether this particular review is right or wrong, positive or negative. The baseline algorithm can be proposed. In this particular example, was proposed by Pang and Lee, and it would include the typical features, typical NLP steps that we were discussing before. So it's a tokenization, is a feature extraction, is of course a test data set, and classification. So sentiment tokenization issues include quite a number of something that we generally don't see in a typical NLP task. Of course, something easy like HTML and XML markup extraction, but also we have different social network related markups like names, hashtags, we have capitalization, we have phone numbers and dates, we have emoticons, and all these things need to be handled. We even have these quotes emoticons that actually consist of normal characters and signs. So there's some useful code. Christopher Foss sentiment tokenizer and Brendan O'Connor Twitter tokenizer. We can actually use that because it will be helping you to split the sentiment, split the particular social network or MDB reviews into tokens in a more complex and more useful way as compared to just splitting them by the space. So based on the previous work, we can figure out 4 types of features. Some syntactic features, some semantic features, link-based features, and stylistic features. If you talk about the first 2, they are most commonly used, and it can be part of speech plus punctuation, or it can be like in other research, they also were using part of speech and modifiers. So what is syntactic features? Basically, it's utilize the basic principles of how the sentences get constructed, and you can use them in a different ways. So you can extract so-called parts of speech, nouns, pronouns, adjectives, etc. And then also you can look for patterns, not just part of speech, but part of speech plus punctuation, noun, comma, etc., etc. So this is syntactic features because they are talking about the syntaxes. Then semantic features, they are going deeper into the meaning, right? So for example, point-wise mutual information is like a measure of association of user information theory. So it's again, we are coming into information theory. And the main idea here is that if a phrase has a better association with the word excellent, then with the word poor, then it's positively oriented with the vice versa. Of course, you can even come up with more advanced deep learning based on features that are related to meaning. So some word embeddings type of data representation approaches like word-to-vec, etc. It also can be applied here. It's just they are not in the slides, but think of it that if you have some positive sentiment and then you have word-to-vec close score to that word, then it's likely that that word will be also positive sentiment, and therefore you can also probably use it as a positive sentiment and adjust your classifier. There's also some link-based feature extraction that, for example, based on the web pages links, or you can also go for some stylistic feature extractions. or it's called stellometric authorship studies in the sentiment classification. So basically, you can have different authorship styles, like have students and also have professors. And these styles can be characterized by particular ways of how people write. Like students don't really put the proper punctuation. They use different words, abbreviations, and let's say professors are very formal. They have proper punctuation, formal way of writing, limit course of words and abbreviations. And then based on that, you can actually split your sentences that you want to classify into different buckets, and therefore after that you could also classify them differently, increase your accuracy. Examples of stylistic features can be formal greeting versus informal greeting, average word length, frequency distribution, and many other things like frequency of use, punctuation, etc., etc. So these all stylistic features also can be incorporated inside your algorithms to do a better jobs. So how do we handle negations in a sentiment classification? Well, negations can be, negation is, of course, I didn't like this movie and say I like this movie. So we could also think of which words we want to use to really anchor our classification algorithms. Should it be related to, let's say, how does the particular negation affecting the next going consecutive word or not? So so if you use all words, not just choose particular words, right? It's actually generally in practice works better, and at least on the data. So if you actually incorporate some artificial adding not to every word between negation and the following punctuation, then this could help you to change the word to having a much easier type for machine to really recognize this word. So for example, I didn't like this movie, but, yeah, and then you can translate this didn't not like not this not movie, but I, and then you can say that not like, right? And it will be converted into not movie. And this process later will help you to predict a better sentiment, or more accurate sentiment based on this punctuation. So when we want to do some supervised classification of sentiments, we need to set up some test data sets, and you can use a cross-validation. You probably have heard about cross-validation inside your machine learning course, but just to remind you that cross-validation is when we're splitting our data sets into training and test sets, and then we do it randomly. So for for 10-fold cross-validation or 5-fold cross-validation, like here, you can see that in different iterations, we use let's say nine parts of the data as a training set, and then the remaining 10% of the data for the test. And then we shuffle it again, and then we use another part for training and then testing. And this will help to kind of let you know what will be the results and what will be the predictive power of your algorithm. So you won't bias to particular training and testing set. So you can use your you can use your test set, and you can use cross validation to basically train your supervised algorithm. And then after that, you will see the report of average performance of your algorithm for the 10 runs in case of 10 fold cross validation. So we set up a training data set divided into 3 equal parts, size 4s, and perform 3-fold cross validation. This is one of the examples for smaller data sets. Then you can run the classification using different classifiers like native bias, like SVM, like maxent and max entropy. And then after that, you can see the performance of these 3 classifiers for different types of features. Like unigrams, you can see unigrams plus bigrams only, the unigrams and part of speech, adjectives, top 233 unigrams, so basically top words, and unigram from position of the word, etc. So you'll get different feature sizes. And you can see that unigrams with bigrams provide us actually a better performance overall when get applied to SVM, right? SVM classifier. And this basically tells you that sentiment analysis is in a large feature spaces, when we consider not just all words, but also the combinations of the words in general, can provide us quite a good performance. So you can see this performance of this VM. This is just one of the examples, but you could leverage this for your future lab that you're doing. So why it's difficult to classify reviews? Because reviews have a lot of interesting words that have a very controversial meaning, and there's also a different order, and sometimes we have a lot of positive stuff in the beginning, but then in the end, it can't hold up. So this film it should be brilliant. Sounds like a great plot. The actors are first grade, and the supporting cast is very good as well, and Stallone is that to deliver a good performance. However, it can't hold up. So can't hold up is actually the key point here, the most important. But before that, we have so many positive words that tell us that sentiment of the sentence could be very good. So we might end up not classifying it correctly. And then you can say that, let's say another one is very talented, Licorice Face House, but it's not so good either. I was surprised, right? Surprised is generally a neutral word. Very talented is positive word, but not so good either is actually something that really need to be handled in the end and need to be emphasized when the prediction is done. So we also tend to use such things as sentiment lexicons and lexicon-based algorithms, and these algorithms help us to anchor these keywords that really define the sentiment later, and based on these keywords we can really do a much better job on the sentiment in the sentiment analysis. So so basically when you look in positive and negative words, the positive words can be spectacular, okay, the negative words can be lousy, unpredictable, and so on. And you can have lexicons for that. So you can have a very simple heuristic baseline when you can have counting the kind of probabilities, right? Or just counts, basically counts the different types of words, like positive terms, negative terms, and then you can see which terms prevail, and then if the positive terms are prevailing, then that could be decided as a positive. It's very simple, but you need to have a very good sentiment lexicon. And interestingly, for some specific task, like let's say predicting of sentiment of machine learning course in ITMO towards particular tutorial questions, right? If you have a very good lexicon about that, actually this simple approach can provide a quite a good performance. But of course, if you'll be looking at some other type of more comprehensive systems, you can also look for, let's say, general inquirer. General inquirer is one of the systems that helps to predict the sentiments, and you can actually use it. It's developed by Harvard, and there's a list of categories available. You can download that, and you can even download it in a spreadsheet. So it has 1,915 words as a positive categories, and also 2,291 words as negative categories. You can also have them strong and weak, active, passive, observed versus undistrusted. And I really recommend you to use this for your labs, because this is something very useful, very simple, but it actually can really help you to do a better job, because you're no longer dealing with generic algorithms, but you also can incorporate a lot of industry knowledge by employing these lexicons inside your algorithm. So this is an example. You can see there's many different columns inside: positive, negative, affiliation, strong, power. So it really tells us a lot about different types of sentiments inside there. And we also have LIWC. LIWC have been covered in a previous lecture. Basically, this is a personality-related categories. Last time we were talking about them as potential features that can be used by you to really do a better prediction of personality or text classification. But particularly, it's very useful for sentiment, because LIWC can really help you to relate dictionary the different categories of words to particular personality types. So the Pennybacker dictionary was invented in 2001, but also now they have a much more advanced hierarchy version with the subdictionaries and sub-hierarchies. And examples of the LAWC categories can be some affective process, negative emotions, bad, weird, hate, problem, tough, positive emotions, laugh, niece, sweat, sweet, cognitive process, like maybe perhaps guess like I'm thinking about something. So I am in the process of thinking. We have pronouns, negation, no, never. We have quantifiers. And based on these categories, you actually really can employ your NLIWC, like you can see the list of these categories, into your algorithm as a features or belong of your particular words in a particular LWC categories that are useful for sentiment prediction. And you can use it for training your models, and it will be also very, very helpful. So I recommend that. Just a couple more LWC categories. Look through the slides. Once you'll be doing your sentiment classification lab, look through the slides one more time. It's actually enough information for you to have a very good direction on how you want to program and code your lab. So there's many applications of personality analysis, like, despite the sentiment classification. For example, we can have like extraversial words, and therefore our algorithms can further infer that extroverts might also have more positive sentiments around, or more stronger, maybe not even positive, negative, not polarity, but rather about the strength of the sentiment, and many other interesting categories you can be used by you from the LWC categories. There is so-called MPQA subjectivity cues lexicon. It also defines the keywords, but also it tells you which one is each word annotated with in intensity. Like, is it a strong word? Is it a weak word? It can be used by again by your algorithm to predict the different personality types, and you can feature engineer your data to split your text into the buckets according to the different categories for the MPQA, and then later you can use it for sentiment analysis. Of course, this one is my favorite, the sentiment WordNet. You probably have heard about the WordNet. It's like a hierarchy of many words. The relation, which are synonyms, which are the parent categories in the hierarchy, which are the lower categories in the hierarchy. So the good thing that there's also a version of WordNet that is annotated with the sentiments. And from there, you can really not just infer the features, whether these particular keywords are positive or negative. So your sentiment classifier can do a better job in classifying a sentiment of a sentence or a paragraph or a document. But also you can, if you know further, so you will know further, you can also see the relationship between words. And let's say one word is positive, and then its synonym is very likely to be also positive, even though sentiment WordNet doesn't have a sentiment label on this kind of word. So this is an example of sentiment WordNet. They have a positive score, negative score. They have different words in synset, and they have a glossary explaining what that means. It's really huge. And by the way, you can combine sentiment WordNet with the ImageNet, which already have image concepts, and actually you can predict the sentiment of the images by just combining these dictionaries together and training the proper machine learning models. Or it can probably just be like a very supportive feature for your image sentiment classification. The bad news that some of these dictionaries are quite controversial between each other, particularly with SentiWordNet. So the advantage of SentiWordNet is, of course, that SentiWordNet is really huge. It's a really huge project, but disadvantage of SentiWordNet is that it disagrees 25% with most of other lexicons. Probably because it's quite big, right? So you can employ SentiWordNet, General Inquirer, probably is the most productive one, LAWC, Opinion Lexicon. You can employ all of them, and you'll get a better performance of your algorithms. So just a few words on the disagreements. And I think disagreements are majorly happening because of the different vocabularies on the basis of this sentiment analysis. But we also see that they can explicitly disagree with each other, that they supply opposite polarity values for a given word. So it's also enabling problems. To handle the disagreements, we can we can use particular lexicons rather than the rest, like gives them a higher weight. or you can combine the values from them. It can be a little bit like ensemble learning when you combine the meanings from different lexicons to do the final analysis and prediction. So emoticons is also very useful in sentiment analysis, and also there are emoticon dictionaries. So basically, when you see emoticons, especially when you analyze social media data, this is very, very useful for you to figure out what is the sentiment of the final sentence. And you are all familiar with emoticons, so I wouldn't go too further. How they can be used: you can actually segment the emoticons. You can segment the text, you can documents and text. Then you can detect the emoticons inside there. Then you can do emoticons-based sentiment analysis. You can do another preprocessing and text-based sentiment analysis, and you can do ensemble together to figure out whether the emoticons actually fit the meaning, and then you can decide which source is more useful for you to predict the final result, or maybe you have confidence in both sides, and then based on these two confidence, you can also do a better job on predicting the final result. So yeah, this is just a rough explanation. You can have this emoticon lexicon, a database, and it helps you to do final prediction. So if you look in the links on the bottom, that's a statistic of emoticons on Twitter. So it could actually be helpful for you because you'll be working on Twitter data. You can also learn sentiment lexicons, and this is another important tactic. As you can see, last time when I was showing you the numbers, words in each emoticon, these numbers were not very big, not very huge, and you wanted to probably extend this number to make the lexicon evolve with the real words that people are using. And therefore, it's important to extend your lexicons, extend your meaning, to develop them to be more sensitive to particular norms of usage in specific domains. So you can bootstrap lexicons because just lexicon itself is not sufficient amount of information, and there are a couple of ways to do that. I'm not going to read this first family name, just read by yourself, starting from H, but there's a couple of intuitions for defining the word polarity. So, for example, activities conjuncted by and have the same polarity, but adjectives conjuncted by but do not have the same polarity. Fair, bad, brutal, fair and legitimate, corrupt and brutal, right? So then by using this, you can already basically see what the polarity is the same, and then you extend your hierarchy, extend your lexicon to have more adjectives inside there by just looking into browsing through your text, matching the synonyms, looking the conjunctions, and then use these conjunctions to populate your lexicon further. So you have some seed set. This set can be taken from some known lexicons at Mortnan or LWC, and after that you can further use your algorithm as I just described to populate it and draw it further. So you can just you can just do it this way. You can have positive 657 positive and sensible and basically the words. You have negative ones, and then you can further extend it by this seed set by having growing it through the conjunctions. And you can see that agreement is over 78%. So basically, if you go through your whole data set and then you extend your lexicon by conjunctions, your final result in lexicon will be really huge. And at the same time, you would not have many issues with the agreement between the new added members of this lexicon. This will be really helping you. So yeah, you can see the statistics, different orientation, same orientation, basically is what I say. And you have each conjunction token in classification according to 3 variables can be split into conjunction used, the type of a modification, maybe a positive, predictive, etc., and then also number of modified nouns, singular, plural, right? So basically singularity or plurality of the noun around that. So you can extend this source, and you can use, let's say, you can use search engine to grow your lexicon. You can, for example, use query suggestions to see what other queries people search, or you can just see the was nice and like, let's say, you can search for this query and see what will be the query results, and then that will tell you what are the phrases used in the website, and therefore you can extend it. From my side, I would add that you can also use Google Keyword Planner, so you can extend your lexicon also based on the real-world searches from Google, and it's all free, so you can use it in your research. It'll be actually quite innovation for you. So nice and helpful, nice and classy, and then classy and helpful can be added into your lexicon. As another example, nice but a bit pricey, but was it enough and not sufficient? Pricey can be added as a negative ones inside your lexicon. So then you can have a supervised classifier that assigns polarity similarity to each word pair resulting in a graph, and assign a similarity value of 1 to adjectives connected by the same orientation, 0 to different orientation, and 0.5 to adjective pair was not connecting links, right? So then you have this kind of graph, and then you can do graph clustering. So once you cluster this graph, you can get quite a bit of new new positive, big number of new positive words inside your lexicon, and also negative ones inside. That will be helpful for you. Will be helpful for you to extend your lexicon. The following in the right bottom corner is basically just a selection of the partition for the clustering. So just think about it of a clustering of groups of the words that had conjunctions and that were queried from search engines. So that's how you can grow. So then you can output your polarity lexicon with a high accuracy up to 92%, and you have many more adjectives that you had in it before. You can use WordNet to learn polarity. This one I described before. So basically, you can just traverse the WordNet based on the different scene sets, based on the hierarchy of the WordNet, based on the synonyms and antonyms inside there, and then that's also how you can look for different groups of polarity. So this was another paper in 2004. You can also look at how they did it. You can learn polarity in this way. And generally, idea is here like this. You don't just need to use your original lexicon. You probably want to adapt your lexicon to fit it into your particular task, your particular data. And it can be really domain specific and can be more robust, have much more words inside there if you employ a proper learning strategy. And a couple of these learning strategies has been shown to you just now by extending it through the existing taxonomies like WordNet, by doing queries in the search engine and other platforms to get more data and see the conjunctions and link them together to extend. If you can do this for your lab, it will be really very big plus, because you will be populating new data sets and you actually have a very big opportunity to do a much better job in your industry and in your lab if you'll be doing that. And of course, the intuition says that always want to start with some good seed words, and then you can further extend this seed set to do a better job and to extend your lexicons. There's also a couple of challenges. For example, tweets are user-generated and more difficult to use. You need to learn more opinion words, and previous methods do not really work well when it comes to social media. So overall, there are a couple of other interesting sentiment tasks that you can tackle to. So for example, if you look at just sentiment classification as a broad traditional topic, you want to classify sentences or documents or reviews or aspects based on the overall sentiments expressed by the author, positive, negative, or neutral. And you might want to have a similar topic-based text classification. So let's say topic words are important, sentiment classification, sentiment words are more important. So if you can compare them to each other, when you talk about classifying words in the topic, something related to this topic, let's say banking, then you have to have a banking words inside there for you to do a better job in classification of the topics. If you want to classify the sentiments, then sentiment words from LWC, from other lexicons, or some feature that you taken out related to sentiments are much more important. This is like one of the key learnings from this lecture. So you can also do sentiment classification on different levels. You can classify it on the sentence level. So you want to classify of the sentiment of the sentence and figure out whether there's opinion inside the sentence, whether there's a polarity inside the sentence. So this is a beautiful bracelet. So this is sensitive, subjective or objective. Is it positive, negative, or neutral, right? So you have to figure it out. And there's no answer to this quiz because you need to have a lot of context about that. And therefore, we also have a document level classification that have a little bit of context around each of the sentence, and it actually helps you to identify sentiments better. And also because of this reason, we don't usually identify the sentiment of, let's say, particular post, but rather the paragraph or maybe even the whole document. But of course, we also have to assume that this document is focused on the same object, and it's only one person writes inside the document. Negative examples of this could be something like, let's say, secretary writes in behalf of some important guy in their Twitter, so it will be contributed by different people, but also maybe documents can be focused on different objects. And then if they're focused on different objects, let's say Twitter timeline, right? Every time you're talking about different things, then it will be also hard to detect the internet. So sentiment. We also can do classification of sentiment on the aspect level. When we want to identify and extract objects aspects that have been commenced by opinion holder, and then also the polarity or even a group aspect synonyms. And if you want to look at this last example, you can see that, for example, camera reviews is a good example of the aspect classification. When for example, positive sentiment comes. This picture's coming out as a camera amazing. Overall, it's a good camera with a really good picture clarity. But negative sentiments could be the pictures come out hazy if you can't shake even for a moment during the entire process taking a picture. You need to know that hazy is actually a negative aspect in relation to the camera classification. Otherwise, hazy is just a neutral world. And I think this is quite a bit of challenge when you want to classify the sentiments of the particular field or particular relation to particular aspects. Another example could be focusing on a daily rag about 20 feet away in a brightly lit room during the day. Pictures produced by this camera were blurry and it's shade of orange, right? Shade of orange is not good, but we need to have a knowledge to know that shades are generally not good inside. And also blurry is a neutral word, but we want to know that it's for camera domain is actually considered to be negative. And another one is a battery life, for example, right? Like if you're going for, let's say, for your camera, for your phone, long battery life is positive, short battery life is negative, but you have to know that this is something very important, otherwise you won't be able to really do the efficient classification. Okay, so these are the examples. You can also find this aspect attributes targets of sentiments. You can use the frequent phrases and rules. Like, for example, you can find the frequent phrases across reviews, fish tacos, and find a rule that occurs right after sentiment word. So great fish tacos, and then great and fish tacos will be actually the aspect, and great will be a sentiment word. So once you know the sentiment word, you can also find aspects nearby to the sentiment words is one way to do it. For restaurants, hotels, aspects are well understood. There's already existing taxonomies of the aspects, so you can just follow that. For example, for iPhones, there's a lot of relation to hardware, software, quality, service support, and also the hardware have a camera, have a battery life. So these aspects already have a very well-defined what is good, what is bad, and you can just tap into these databases to do a better job. So we can just use these existing taxonomies with relation to particular industries, let's say to iPhones, or let's say to phones, and based on that you can do a better job in your aspect sentiment classification. So if you talk about reviews, you can actually extract text, you can do sentiment classification, you do aspect classification, like basically figure out which aspect is talking about, or it's similar to topic classification, and you can aggregate these two both to produce a final summary, and that will have a better quality, hopefully, because you're not just classifying sentiment, but you're also incorporating aspects that you have also predicted from the text. So you use aspect, you use sentiment, you aggregate together, you get final summary, which is more accurate for sentiment analysis. So if it's summarized about this, sentiment is usually gets perceived as a classification and regression task. Classification where you have fixed categories and you have the confidence of that, or you can also have the regression task that basically giving you the level of the sentiment. Negation is very important to use because negation is inverse the meaning, inverse the sentiment. You want to use all words. And basically, words and diagrams help better even when it comes to SVF, not just naive bias, as I said in the slide. And finally, subset of words may help in other tasks, like for building polarity lexicons or getting seed sets for growing your lexicons. These are the references. You don't need to read all. You can go just for the references in the beginning, read those 2 papers first, go through other papers inside, read them as well. And we're going to talk about spam removal, very important topic. So in spam removal is one of the key tasks Google and Facebook of today's of our world are very, very focused on, because that defines how well the social networks are working and how well the service is provided to the final customers. And if final customers are happy, they're getting their revenue. Therefore, this is one of the key topics modern machine learning social media industry is trying to tackle. Be on the next lecture, understand it, and then maybe you can get a job in Google very soon. And for now, I'm gonna get my friendly assistants to help you with some more details on the lab works, on how it gets executed. And for the tutorial 2, it will be on a sentiment analysis, and it will be after the next lecture. So you have 1 week to think how to answer questions using lecture notes, but also to digest material to have better answers. Have a good day, and bye.